Have you ever wondered how companies like Amazon or Netflix manage those absolute mountains of data they have on all of us? Well, they don't just dump it in a folder somewhere, they build with it. And to build anything that's going to last, you need a blueprint. So today, we're going to dive into exactly that, the blueprint for data, which is all about data modeling and design.
So let me start by asking you this. If your data was a building, what would it look like? Would it be a magnificent, well-planned skyscraper, or would it just be a random pile of bricks? That plan, that structure, that's what we're exploring today. It is literally the difference between organized, useful insight and just pure digital chaos.
And you know, this isn't just some abstract idea. It's a core discipline in the industry. This diagram right here comes from the official data management body of knowledge, or DAMA-DMBOK, which is basically the Bible for this stuff. See that highlighted wedge? That's data modeling and design. It's a central gear in the entire machine, connecting everything from data security to architecture. It is the essential process that turns a business idea into a technical reality.
So what is data modeling exactly? Well, think of it like being a translator. It's the process of taking what the business actually needs, the requirements, and turning that into a super precise technical plan that developers can actually build from. It's all about figuring out what information truly matters and then drawing the map that shows how it all connects.
Now, a good blueprint isn't just drafted in one go. You don't get it perfect on the first try. Just like an architect, a data modeler refines their design through different levels of detail, moving from a really high-level sketch all the way to a detailed construction plan. So let's break down these three levels.
First up is the conceptual model. Seriously, think of this as the initial napkin sketch. It's the 30,000-foot view. All it does is identify the most important concepts the business cares about. We call these entities, and shows kind of how they relate to each other. It is purely the big picture, zero technical jargon allowed.
And this slide shows that simplicity just perfectly. We have three core things, three entities: a school, a student, and an application. The relationships are just as clear. A school contains students, and a student submits an application. That's it. It's a simple, clear diagram that anyone in the business can look at and immediately understand.
Okay, next, we add a layer of detail with the logical model. This is where we take our napkin sketch and start defining the specifics. It's like adding the rooms, the windows, and the doors to the building plan. We define the specific pieces of information or attributes for each entity. But, and this is key, we're still not locking ourselves into a specific database technology.
And right here, you can see that next step in action. Our student entity isn't just a box anymore. It now has specific attributes like student number and name. The school has a school code. We're adding all the necessary details to make the model concrete. But notice, we still haven't mentioned a single technology. We're just adding substance to the sketch.
Finally, we get to the physical model. Now this is the master blueprint that you hand over to the construction crew. It translates that logical design into the specific language and rules of a chosen database system. Whether that's Oracle, SQL Server, maybe a NoSQL database, this model has all the technical nitty-gritty, like data types and indexes, that you need to actually go and build it.
So we have our levels of detail. But what are these models actually made of? Let's take a look at the fundamental bricks and mortar that make up any data blueprint.
You know, every data model, no matter how complex, is built from four fundamental components. We've got entities, which are the main things we track. We've got relationships, which show how those things connect. Then attributes, which are the details about those things. And finally, domains, which basically define the rules for what kind of data is allowed. Let's break these down a little more. First up, entities. The easiest way to think about them is as the nouns of your data. They're the who, what, when, where, and why of your business. So the who could be a customer, the what could be a product, and the why might be an order. These are the absolute foundational concepts that everything else gets built around.
So if entities are the nouns, then relationships are the verbs. A student registers for a course. And attributes? Well, those are the adjectives. A student has a student number and a first name. And you might notice on the diagram how things like student number show up in a couple of places. That's what we call a foreign key, and it's the magic glue that creates those powerful connections between all our data tables.
Now, think about it. You would never use the same blueprint for a skyscraper that you would for a single-family home. It just wouldn't make sense. And it's the exact same with data models. We don't use the same one for every single purpose. There are different architectural styles, and each one is suited for a very specific job.
This table gives us a great little overview.
You have the classic workhorse, relational models. They are all about data integrity and cutting down on redundancy. Then you've got dimensional models, which are built for one thing and one thing only, speed, making them the absolute foundation of business intelligence. And then, of course, you have all the modern NoSQL styles, which are designed for the massive flexibility you need to handle today's complex, often unstructured data.
Let's really look closer at the two most common styles with an analogy. A relational model is like a super detailed city plan. Every street is named, every address is unique, and there's absolutely no duplication. It's perfect for things like an order entry system, where you need everything to be just right. A dimensional model, though, is more like a subway map. It's simplified and optimized for one goal, getting from point A to point B as fast as you possibly can. This makes it absolutely perfect for data analysis.
And we can't forget about the new kids on the block, NoSQL. Now, this isn't one single style, but a whole family of them, document, graph, key value, all designed to handle the messy reality of modern data. We're talking documents, social media connections, user session data, you name it. They trade some of that rigid structure you see in relational models for incredible flexibility and scale. That's why they are absolutely essential for big data and modern web applications.
So you've drafted your blueprint. Awesome. But how do you know if it's any good? Before you start construction, you need an inspection. And in data modeling, this means applying some key principles to make sure the final structure is going to be stable, efficient, and just plain sound.
The main inspection process for relational models is called normalization. And as the slide says, its number one goal is to eliminate redundancy. Now, why is that so important? Because you want every single piece of data to live in one and only one place. This prevents the kind of nasty inconsistencies that can corrupt your entire system, and it keeps your data clean and reliable. Normalization follows a series of rules, or normal forms. Let's just simplify the first three. First normal form is basically like giving every house a unique street address. No two can be the same. Second normal form makes sure that if you're talking about the Smith house, all the details like the color of the paint or the number of bedrooms are about the whole house, not just the mailbox out front. And third normal form is the final cleanup. It makes sure that the details in the Smith house record are only about the house, and not, for example, about the mailman who delivers their letters. That information belongs somewhere else. But quality isn't just about technical rules. You know, this quote here really nails it. At the end of the day, a data model is a communication tool. If stakeholders can't easily read and understand your blueprint, mistakes are going to happen. It's just inevitable. So clarity and good organization are just as critical as any technical perfection. So the next time you use an app, I want you to think about that hidden structure that's making it all work. A well-designed data model really is the unsung hero. Because without that solid blueprint, you don't have a skyscraper of valuable information. You just have a messy, unusable pile of digital bricks.